Hello, awesome CC3 students. Welcome to Wednesday, April 22nd, and our instructional video for today. So today we are just going to go over an IXL code. So the code for today is, I believe the code, wait, hold on, I'm looking at it. It's KZD, and we will post that in the Google Classroom. And it's all about interpreting points on a linear graph. So without further ado, let's go ahead and get started. The first thing you're going to do after you sign into IXL is type in the code KZD. The description is interpret a graph word problem. So we're going to click on that. And by the way, I have also recommended this skill for you. So when you go to your recommended skills, this should pop up. So the idea here is that you're going to be given a graph. It's going to have a line on it. But what's most important here is reading the title of the graph, which is always at the top, and what the X and the Y axis represent. So by the way, I don't know if you've ever seen this before, but you can always learn with an example. If you read through the example, it will kind of teach you how to do that problem, and then you can always click away from it to go back to the practice. So if we're looking at the example here, says this graph shows how the cost of a charity gala depends on the number of attendees. That a charity gala is usually like a party that you'll throw, obviously to raise money for some type of charity. And then attendees usually just means people who attend. So if you look, the title of the graph is right there, cost of the charity gala, right there. The cost is the y-axis, so the vertical axis, and the number of people attending is the x-axis. So points on this line represent possible pairings. So for example, if I look at this and I go, okay, what does this point represent right here? That means the 80 attendees, so 80 people who attend, it would cost $800. So if you look here, the question is, how many attendees can there be at most if the budget is $800? So to answer that question, I'm going, okay, well, let me trace this up to $800. And I look over, and that is at 80. So down here, it tells you how to do that. Find 800 on the y-axis. So we traced it up and we found 800. And then move right until you intersect the graph. So that's what we did first. Then it says now move down until you intersect the x-axis. So after we did this step, we traced it down and we landed on 80. So because we intersect the x-axis at 80, that means that there can be at most 80 attendees. That was just a practice problem. So let's see if we can use that same process to do our first problem. So it says this graph shows how much money, or the amount of money left to raise. How the amount of money left to raise is related to the number of pies that Judy has sold. So Judy must be selling pies to raise money for something. So the entire graph represents money left to raise. So maybe she has a goal set in mind of how much money she wants to raise. And then this is how much money she needs to raise to meet her goal. So the y-axis is the money left over, and the x-axis is the number of pies sold. So all of these represent different possible values. So after she sold one pie, she had between $70 and $80 left to raise, so on and so forth. So take a look here. After Judy sells 5 pies, how much money will she have left to raise? So we're given this information, 5 pies. Am I going to look at these numbers over here if I'm given 5 pies? I don't think so. I'm going to look at the axis that shows me pies. So I'm going to where it has 5. So this shows me this is where Judy sold 5 pies. Just like the example, I'm going to trace that up to the graph until I hit a point on the line. Now, to find the amount of money that she'll have left to raise, I'm going to take my cursor and I'm going to go over to the y-axis. And it looks like the amount of money associated with 5 pies is 50. So after selling 5 pies, she still has to raise $50. Let's see if that was right. All right, look at that. Pretty cool. Okay, so it brings us to another graph. So again, whatever you're given, find that point first, trace it over to the graph, and then see what point corresponds with it on the other axis. All right, example 2. This graph shows how the amount of jelly Emer, I don't know what that name is pronounced, Emer, has left is related to the number of sandwiches he makes. So he's making some type of sandwich with jelly. I assume it's peanut butter and jelly. I can't imagine just having a jelly sandwich, but whatever. All right, so this represents ounces of jelly remaining. So probably he's using like a jar. So based on the number of sandwiches, how much is left in the jar? So it looks like the jelly started with 90 ounces and then he made 90 sandwiches and then he was out of jelly. So let's see what the question says. Up to how many sandwiches can Emer make and still have 60 ounces of jelly left? So we're given a number of ounces. Which axis represents ounces? Ounces. It looks like the y-axis represents ounces. So if we go by how we learned in the example, we're going to go to where it says 60 ounces on the y-axis and trace our cursor over to the line. From here, once we find that point on the line, we're going to trace it down to the other axis, and that tells us the number of sandwiches he made. So he can make up to 30 sandwiches using and still have 60 ounces of jelly left. So our answer here looks like it's 30, and we got a little keep it up there. All right, let's do one more of these examples before we move on and jump a level. This graph shows how the number of roses Tammy, a florist, has left is related to the number of arrangements she puts together. So an arrangement basically means that she's putting together like a bouquet of flowers or like a really pretty amount of flowers in a vase or something like that. So the entire thing represents roses remaining. So if you look at this graph, it looks like she starts with 100 and then she's able to make just over 30 arrangements out of all of those. So let's see what it asks us. If Tammy puts together 20 arrangements, how many roses will she have left? So we're given 20 arrangements. Which axis are we going to use? Let's see. Y-axis is roses remaining. Here it is. X-axis is number of arrangements. So we're going to go to 20 arrangements on the X-axis. Trace that value up to the line until we hit the point on the line because that's an actual solution in ordered pair. And then trace it over to see, it looks like she will have 40 roses left after making 20 arrangements. So let's see, 40 roses left, click submit, and there we go. All right, let's go ahead and jump a level here. So that was only up to a SMART score of 28. Now let's get all the way up to a SMART score of 81. So now we're getting past kind of the preliminary problems and going into some that might be a little bit more challenging. Let's see. This graph shows the amount of dough Ayana has prepared. How the amount of dough Ayana has prepared is related to the number of hours she spent working at the bakery. So she's a baker, it looks like. So the total graph is amount of dough prepared. It looks like you have the y-axis is the amount of dough prepared in kilograms compared to how many hours she actually worked. All right. How much dough did Ayana prepare if she worked for 4 hours? Which axis represents hours? 4 hours. It looks like the x-axis represents hours. So we're going to go to where it shows 4 hours, right here. From here, we're going to trace up to the line. I think I see why this is a little bit tougher one, because this point is not on an exact coordinate. You see that? It's actually between 8 and 9. So that's probably why this is a little bit tougher. So it looks like it's about halfway between 8 and 9. And if you don't know what the exact answer is, let's just look at let's look at the possible answers and pick which one makes sense. The first one is 8.5. Is 8.5 between 8 and 9? Yeah, it looks like it. Let's just double check the other ones. Is 6.5 between 8 and 9? No. For 6.5, that looks like it would take her 2 hours. 7, no, 7 would take her between 2 and 3 hours, and we know it's not 8. So it looks like at 4 hours, she's able to make about 8.5 kilograms of dough. Let's see. And we got it correct. All right. So let's look at this one here. This graph shows how the cost of Roseanne's retirement party depends on the number of guests. So you would think that this graph is going up because the more guests that you have at a party, the more expensive it's probably going to cost. So let's see, if there are 6 guests, how much will her party cost? Let's see. So let's go to where you see guests, and we're going to be looking at 6. So I'm starting at 6. I'm going to trace it up to the line. And look at that. It's between 2 values again, which probably means it's going to be a decimal. So let's trace it over, and it's between $8 and $9. Let's see. So which of these values is between $8 and $9? I think $8.50 is the only one. Click submit, and there we go. All right, we're going to jump one last level and see what it looks like. Here we go. This graph shows how a sapling's height depends on its age. A sapling is, I think it's related to a tree, like it's like a growing tree. We'll see. I might have made that up. I don't know. Okay, the height of the sapling is what this entire graph represents. The y-axis is the height in inches, and this is its age in years. So you would think over time it would grow a little bit taller. So how tall was the sapling when it was 6 years old? Let's see. So we go to years because that's what we're given, and we find 6, and we trace it up to the line and over to the left to give us the height of the sapling at 6 years old. And it looks like the height here was 40 inches. And now we're entering the challenge zone. So for those of you who think that you're up for a challenge, like maybe this is too easy for you, this is what we'll be looking at. So we'll do one of these together and then we'll end the video. This graph shows how the number of tartlets Owen can bake is related to the number of additional eggs he buys. So a tartlet is like a little baked round. I watch a lot of baking shows, so that's how I know that. All right, so here we go. The entire graph represents tartlets baked. So how many he bakes compared to the number of additional eggs he needs. So let's see, how many additional eggs does Owen need in order to bake a total of 8 tartlets? Let's see. So we're going to 8 tartlets. Does the x-axis represent tartlets? No, that doesn't represent tartlets. The y-axis represents tartlets. So we're going to where there are 8 of them. So we go up here to 8 tartlets and trace it over to the graph and then trace it down. So it looks like to make 8 tartlets, Owen needs to buy 8 additional eggs. Let's see if that's right. Hey, we got it right, and now we're at a SMART score of 92. Okay, so that is your IXL code for today. If you have any questions at all, please email me or email Mr. Adam. We are here to support you, but we don't know how to support you if you don't ask questions. So this IXL code is due by Sunday at midnight, and we will have a video conference session available tomorrow to go over this in more detail if you need it. Have a great rest of your day. Happy Earth Day, and I will talk to you all soon.